All right, in this example, it says consider the region enclosed by y equals x squared, y equals 0, and x equals 3. But this time we're finding the volume of the solid if it's we revolve this around the line x equals 3, not one of the x-axis or y-axis. It's a little different. So I'm going to start off by drawing y equals x squared. And so just in the first quadrant, x equals 3 is over here. Y equals 0. And so it's this region in here. And we're going to rotate this around that line x equals 3. So it's like rotating around the line, the y-axis. So I'll still have a volume. It's equal to pi limits of integration. Since I'm revolving around basically a y-axis, I get my limits of integration from the y-axis. So I would be adding up all these radiuses from 0 to 9. So this is when x is 3, it crosses when y is 9. So those would be my limits of integration. But the radius is tricky. The radius needs to be solved for x. It needs to be in terms of y. So I'd have y is equal to x squared. If I solve that for x, I have x is equal to the square root of y. All right, so let me make this all the same color. Too many colors going on. All right, so what I'm doing, I need to represent this radius right here. How do I find those radiuses each time? Is it just always going to be 3? No, the 3 is the distance from y-axis to the line x equals 3. So this distance right here, if I want to find this yellow distance, that would be 3, the whole thing, minus, I don't know if all this colors helps, minus the square root of y. So each one, the whole thing is 3, so it'd be 3 minus this part. This part is where I would get like the value at, if x was 2, the y value would be the square root of y. So it's all these over here. So the radius will always be 3 minus the square root of y squared. So that is a little bit tricky. Finding the radius, representing the radius here is the tricky part. If it was just, okay, how can I draw this? If it was like normal, if it said, like if I want to find this region, wrap it around the y-axis, it would just be square root of y. That would be the radius. But this time, I want this piece over here, so it's the part past square root of y all the way to 3. So it'd be the 3 minus the square root of y. All right, so now we integrate. The hard part is finding that radius, representing the radius. So volume would be, okay, so I'm going to write this one out. This would be 9 minus 2 square root of y plus y. So really, I should keep this. And one more step, I will minus 2 square root of y. Square root of y, same thing as y to the 1/2 plus y dy. Volume is equal to pi 9y minus, add 1, so it'd be 3 over 2. Multiply by the reciprocal, 2/3. 2/3 times 2 would be 4/3. Plus 1/2 y squared, evaluated from 0 to 9. So now I got to plug in 9. Volume is equal to pi times 81 minus 4/3. Okay, 9 to the 2/3 or 3/2 exponent would be the square root of 9 cubed, which is 27, plus 1/2 times 3, no, 1/2 times 81, so 81 halves. And that would be a good safe stop. All right, we are going to skip number 7. Number 7 will actually be in the next set of notes. And then we'll finish with number 8. So revolving about a line. So another one, just like the one we just did, this would be good good one to pause this and practice and see if you come up with the answer. So it says, find the volume of the solid by revolving the region bounded by the graphs of 2 minus x squared, 2 minus x squared, and g equals 1, g of x equals 1, and the line y equals 1. About the line y equals 1. Okay, so I'm back. Okay, so y equals 1 looks like this. That's going to be the axis we rotate around. Now, 2 minus x squared. Okay, so if I plug in 1 to that, 1 squared, 2 minus 1 is 1. So it kind of looks like this. And we're going to rotate around that axis. So we're going to take this, and we're going to rotate it around. So we're rotating around basically like the x-axis. So the volume would equal pi from -1 to 1 of, okay, so the actual radius, the radius is going to be in terms of x. So the radius is this much. Okay, this whole distance is function value 2 minus x squared. But all these radiuses are function value minus 1. Because I don't want to include, I don't want to include that part. So it's function value minus 1 will give us the radius. So it's function 2 minus x squared minus 1 squared. All right, so that's a lot of extra. I just wrote that extra complicated for no reason. It would be function 2 minus x squared minus 1 squared. That's the radius. So the volume, I would rewrite it -1 to 1, 2, so 1 minus x squared dx. So it's that thing squared. I would need to expand this. So volume is equal to pi -1 to 1 of 1 minus 2x squared plus x to the 4th dx. Find the antiderivative. It would be what? X minus 2/3 x cubed plus 1/5 x to the 5th. Evaluated from 1 to -1. So this is the first time we have to actually plug in both limits of integration. We can't just plug in 0 and get away with it. So be careful. I'm going to get 1 minus 2/3 plus 1/5 minus whatever I get when I plug in -1. So it'd be -1 plus 2/3 minus 1/5. So if I clean this up, we could save stop it here, but this would be pi times, okay, so that'd be 1 minus, 4/3 plus 2/5. You can combine, you could clean this up even more, but I think I'm just gonna leave it just like that. Oh wait, no. Okay, 1 plus 1 would be 2. Okay, I almost missed that. That'd been bad. All right, so you can clean that up, and I think if you do, you get like 16 over 15 pi. So that'd be the answer. All right, hopefully this helped. If you have any questions, next time I see you in class, make sure you ask them, and thank you for watching.